dynamic programming, the most important topic in algorithm design. So dynamic programming is what? Dynamic programming, like divide and conquer method, solves problem by combining the solution to sub-problems. Somewhat like divide and conquer only. Bit like divide and conquer, but another important thing is that programming, although it is dynamic programming, but there is no relationship with any programming language. Sometimes students used to do mistake thinking that it's a programming concept. There is no, it is related to any programming language like Java, C, C++, Python, okay? So don't confuse with this programming. This is just a technique like greedy algorithm, similarly greedy technique, similarly dynamic programming technique you can call it. See, it works like divide and conquer only. Basically what happens, you have a problem and you divide the sub-problem. Most of the recursive method use a divide and conquer approach only. Here also similar types of things will happen. So P1 will be distributed among n number of problems, Pn. In divide and conquer, what happens? All problems are independent subproblems. All problems are independent subproblems, whereas in dynamic programming, all problems are not independent. That means P will be divided into many subproblems, P2, P3, Pn. If this is P, this is my P2. So there is a shareable portion. That means P1 is sharing problem with P2. So every time sub-problems will be solved, it will generate a table. Let's say this is table T1, this is table T2, this will be table T3 like that, and this will be the last one will be table Tn. In case of dynamic programming, this is what going to happen. Okay? So every time is shareable. So Pn, Pen and Pn minus 1, these two problems also will share something. So these are all tables. While solving sub-problems, P1 will make a table and P2 also will make a table, but it will invoke some information from, that means table 1. P3 also will do some information for T2 or T1 like that. So there is a shareable option is there, sharing opportunities are there in dynamic programming, whereas divide and conquer, all are independent sub-problems. Meaning is that P1 intersection P2 intersection P3, everything is equal to null. No intersection, nothing, no commonality among them. So both it will be using recursion technique only. You have to develop a recursion technique like we did in greedy method. So divide and conquer algorithm. So this difference is very common. What is the difference between dynamic programming and divide and conquer? Many exams you can find this question being asked. What is the difference? So divide and conquer is independent subproblems. Dynamic programming is dependent subproblems. Okay. So in contrast, dynamic programming applies on the subproblems overlap each other. So this is overlapping. This is overlapping. This is overlapping. This is overlapping. Okay. When the subproblems share subproblems, this is the difference. So when anyone asks you what is the difference between dynamic programming and divide and conquer, you have to tell that divide and, although both uses recursive method. When you are solving, if you remember divide and conquer, we have discussed what is that? Karasuba matrix multiplication. That also recursively you are solving, but subproblems, whereas subproblems are not shareable, whereas in dynamic programming it is shareable. This is the basic difference. The dynamic programming algorithm solves each sub-problem just once and then saves its answer in a table, thereby avoiding the work of recomputing the answer every time it solves each sub-problem. So it saves in the table T1, table T2, like that things happen. Okay. So whereas divide and conquer does more work than necessary, repeatedly solving the common sub-problem. Every time it solves the sub-problem without caring which is a commonality that we can avoid. Whereas in dynamic programming, it is stored and saved in a table. Wherever required, we will invoke that table. That's all. So the characteristics of dynamic programming, that means when you develop a dynamic program, you have to follow these 4 options, which is bit similar like greedy method only. First thing is that characterize a problem into optimal. So first of all, it should be an optimization problem. Dynamic programming should be an optimization problem. Recursively define the value of an optimal solution. Compute the value of optimal solution, typically in a bottom-up fashion. Construct the, so 1, 2, 3, these 3 options are for dynamic programming to solve, and then finally if you need an answer, that point number 4 is important. Okay. So step number 1, 2, 3 the basic of a dynamic programming solution of a problem. Whereas if you need solution, then you have to execute step number 4. Otherwise, to solve the problem, these first 3 conditions are enough. So it's a bit like greedy method only. It has to be an optimization from other. Which are the optimization problem we solved in greedy method, like 0-1 knapsack? You can have a dynamic programming approach. And then I think coin change, there also you can have a dynamic approach like that. These are all optimization problems. So this is the basic of. Now I will show you, we will discuss one dynamic programming technique for a very popular common problem which is there in your syllabus. So the problem says that solving longest common subsequence problem using dynamic programming. Longest common subsequence, LCS. Many places you will find this LCS, okay? LCS, longest common subsequence, okay? Now what is longest common subsequence? We'll see. It's a biological application often need compare the DNA of 2 different organisms. DNA of 2 different organisms, okay? If there are 2 different DNA, then only you can say that how some species 1 is close to species 2, right? Let's say maybe chimpanzees and human being will be little bit similar. So their DNA will be little bit similar DNA, but some changes will be there, some difference will be there. So how to check that similarity is there, similarity is this much percentage, similar ACGC. With this we can generate a huge chain. Okay, let's say this is one sequence and this is another sequence. One is S1, this is AC, all combinations and permutations that is possible. Such kind of sample, and then this is S2. Now these samples are given. We have to find which are the common subsequence and then longest common subsequence. So as I was talking in the last slide, so what do you mean by, what is the difference between substring? We have to be a little bit careful about it. Substring and subsequence. Substring and subsequence, okay? Substring is very simple, like if I say this is a string A, B, C, D. So this is, so substrings are A, B, C, A, B, C, D. These are all substring. Whereas subsequence are not something like substring. Substrings has to be continuous. A then AB, AB then ABC. These are all substring of this string S. Whereas subsequence are different. Subsequence can be A, AB also can be subsequence, A can be subsequence, AB also can be subsequence, but AC also can be a subsequence. This is slight difference. That means all substrings are subsequences, but all subsequences are not substring. So A, AB, so longest common sequence you will be given, let's say this is my first sequence is given, this is my second sequence is given. You have to find the longest common sequence. First of all, you have to find which are the sequences, subsequences. So subsequences means, let's say A, AC, and then ACC. These are all will be subsequence. Even in fact, AGG also. That means AGG. This also will be a subsequence. AGGT also is a subsequence. So that should not be, must not be, need not be continuous in case of subsequence. So just tell me AGGT, will it be a subsequence or not? Students, yes or no? It will be a substring. It is not substring. Sometimes students used to get confused. Substring has to be continuous. Subsequence can be, but it has to be in the forward direction. You cannot say AA, you cannot say GC like that. You cannot backtrack, okay? That is not possible. So it should be forward direction, but it can skip some characters in the forward direction. So this is one thing has been given, let's say. Okay, so we have to find subsequence S1 is given, sequence S1 is given, S2 is given, and then you have to find the common subsequence, and you have to find the longest common subsequence. So let's say you have taken A, B, C, D, E, F, G, M, K. This is first sequence. Second sequence is A, C, D, F, G, M, P, H, L. Let's say. And length also need not be, let's say this is M, this is N. Length also need not be equal. So first of all, one common subsequence is A, because both are having A. Then another sequence may be AC. Yes or no, students? AC is there. AC is also there. A here and C there is also okay. ACD. Understandable? ACD from this side. Here also ACD is there. ACDF is also there. ACDF. Then ACDF is also there. ACDF is there. And then what? This is the final A. So what is the A, C, D, E, F, G, M. This is the longest common subsequence. But before that we have many sequences, right? We have A, B. No, common sequences AC, ACD, and then ACDE. Yes or no, students? But among all, which is the longest? This is the longest. So this is what you have to find. Okay, this is what you have to find, longest common subsequence. This is the problem statement. Now how to solve this problem statement? Easy only. We have to develop a recursive equation. Okay, you have to develop a recursive equation. How to develop a recursive equation, that you have to check. So given two sequences X and Y, we say that Z is the common subsequence. Let's assume that Z is the common subsequence. Z. We have given X is this one, A, B, C, B, D, A, B, and Y is B, C, B, D, C, A, B, A. So this length is 1, 2, 3, 4, 5, 6, 7. This length is 1, 2, 3, 4, 5, 6. 7, length is 7 here, length is 6 here. And Z, you are assuming that it is the longest common subsequence, okay? It is a common subsequence. So, what can we do? Okay? So, in the longest common subsequence, the input is two sequences X, and now let's say the length of the X is, whichever it is, length of the X is M, X1, X2, X3 up to X7, X1, X2, X3 up to Xm, and length of the Y is Y1, Y2, Y3 up to Yn. And this is my Z. I am assuming that Z substring is up to Zk. I am assuming it. I am going to develop a recursive equation, then only I can solve it. Okay, and that too tabular format and everything has to be taken care. So this is Y, Y1 to Yn, and the goal is to find the maximum length common subsequence of X and Y. Okay. So characterizing a longest common subsequence. Step number 1. You can solve LCS problem. You can solve LCS problem with a brute force approach. Now if you go with the brute force approach, see the scenario, how the situation. Let's say X is A, B, C, D, E, F, M, K, L, something like this. And X is, let's say, A, C, D, M, K, P, L, G, T, K. Let's say this is size is M, this size is N. Okay? So if you see, what you are going to do, you are going to find the common subsequence and then longest common subsequence. If you are going with the brute force method, so brute force method is something like this. Every time brute force method, combine all possibilities, brute force. So let's say this is A. For A, how many options are there? Brute force. Very inefficient way of doing things. Brute force method. So this technique normally we avoid, but when anyone start to solve any problem, he will start with the brute force method only. Okay. So how the things are happening here? If you see carefully. So basically, how many for with A will check this A. Sorry, brute force way how you will check? You will check A with this A, yes or no, students? Then A with C, A with D, A with M, all things will check. It will go up to this much, A with K. So for one option, you have n number of options. For n options, it will be much more. How much it will be? For this one, you have 2 to the power n number of options. Yes or no? So there are m number of characters at the, so at least this much. I mean, it will be bigger than this. Let's say theta m into 2 to the power n. Something like that is coming. Either it will happen or it won't happen. So 2 choices for each places. So for A itself, you have this many number of options. And then B also this many. So it's like M into 2 to the power for the first character itself. So it's a not polynomial, students. Polynomial time, you remember? Polynomial time, all of you remember or not? Polynomial time is something like that. If you write n square plus twice n plus 1, this is a polynomial. In fact, you can also say polynomial is this 3n n cube plus 2n square plus n plus 1. Up to this much, we will call it polynomial. Okay, maybe n to the power 4 is also okay, but it should not be in the form of 2 to the power n, 5 to the power n. It should not be in the form of x to the power n. E to the power x format should not be there. E to the power x means like this, time will go, it will shoot like anything. So it is a lot of time. Brute force method will consume lot of time. You have to find something else. Brute force method will fail. That's why you are going towards dynamic programming. Okay. Now let's say LCS problem has the optimal substructure property. However, as the following theorem says, so ZK is my longest common sequence we are assuming. Before that I have x which is of size m, I have y which is of size n. Now what is happening? Let's say you have this, x is this and y is this. Let's say my x is A, C, D, E. My y is A, C, E, P. Okay. Now how these calculations is happening, students? Let's say this one A, C, D, E, and let's say this is Q, this also Q. Okay. So what it will do? So this length is M, this length is N, correct? So at the last thing, recursive algorithm I'm going to develop. So last character is matching up. So once last character is matching up, then what I'll do, I'm going to only check if last characters, I'm just from the back I'm trying, last character let's say is matching. So I'll only check this part. Last character is matching means a good thing happens. So what? So A, C, D, E, Q has been matched, and then A, C, E, P, again Q. So last two characters from X, from Y, they are matching up. So if the length is M here, length is N here. So what is the length remaining here, students? No, you talk about M minus 1, and here N minus, very good. Again I'll run a checking algorithm here. Let's say this also, then it will be M minus 2. But this is the best thing happen. And then after that, here it is E and it is P not matching up. We will hold on it. But let's say if the things happen, it will keep going. So first condition is if xm equal to yn, that means this is my xm. Obviously this is mth location. Let's say this is mth. This is nth location. So xn and yn. So this is my yn. Correct, students? X and y is matching up if it is the case. And then here that means my zk that I have taken, the last wala has been matched, which is the kth location. Okay, correct. So this has been matched. So obviously here also k minus 1 will be remaining. So zk minus 1 is an LCS of x m minus 1 and x n minus 1. So another call will be so x m minus 1, x y n minus 1. These two calls. So another x m minus 1. This is x and y n minus 1. These two calls will be there. And then 1 already has been matched. So this first case we have developed recursive equation. If it is the last fellow is matching up, we will just subtract 1 from each of the length, and then we will have another recursive call. If it is good, then it will be m minus 2, m minus 3. Let's say very good things are happening. It will go up to what? M, up to 0th location it will go, and things will be done. But ideally it will not be the case. So this is the first base case scenario we have. This is clear or not? All of you clear? If this is clear, then next time this is not tough. Second condition, A, C, D, E, and this is Q. A, C, E, P. Let's say this is R. Okay, R. And okay, R, and this is okay, fine. So here this is not matching up. So this is my mth position. This is my nth position. It's not matching. So this is like m minus 1. and this is also n minus 1. But now what I'll do, this fellow is not matched. I'll just have a recursive call here. I'll have a recursive call. This is not matching, fine, I'm okay with it. I'll just have a recursive call here. Whether these two guys are matching. Xm not equal to yn. So this is xm, this is yn. They are not matching. Something else is there. It's not q, man. This is q, this is, let's say, t. They are not matching. So what I'll do, I'll just check this part. Whether these two guys are matching. And then I'll also do the other part. That means which is, I'll check this also. This also I'll do. So one is this, another one is this. Just take that one. So whichever gives longest among these two calls, what is the first call? First is this. This case arising when xm not equal to yn. That means the last character of the things, this is q matching up. Let's say this is q, this is t. Not matching, right students? So in that case I will be having one call here, recursive call. Another call will be this. Among these two calls, whichever is the maximum, that I will take. So very simple. X z cannot equal to say LCS x minus 1 y and LCS x y minus 1. These two conditions, if you punch together, it will be what? Maximum of xm minus 1 comma y. This is one call. And let's say give this thing. Another one is x comma y n minus 1. Finally, this is the situation we have here. Nothing is existing, zero cost. Nothing is there to compare. What shall I say? Zero. If q is matching, this is my x, this is my y. So a, b, c, q, a, e, p, q. So q's are matching. Once it is matching, this will be m minus 1, this will be n minus 1. One recursive call will be there. So for that, 1 is coming from one match, and I minus 1, j minus 1. Just m and replace m with I, replace n with j. This is second call. Third call, just now I told this one. I mean, let's say this is q, this is t. So one call will be this, another call will be this. Whichever gives maximum. So ci j minus 1, comma ci minus 1 j. Whichever is the maximum, that one I will pick because it's a longest common subsequence. This is the recursive equation. Now, first, this is, you see, this one, just now I explained, q are matching. So this is c I minus 1, j minus 1. And then this I will explain, till line number 10 and all these things I will explain. And then one is I minus 1 comma j, another I j minus 1. So these functions that just now I explained, it is now here, okay? But when you are actually going to implement a programming thing, that time as I told you, it is a tabular format. So dynamic programming is tabular format, tabular. Tables will be there 100%. Otherwise it won't be a dynamic programming. So I have given these two strings. X is a, comma b, comma c, comma b, comma d, comma a, comma b, and y is this. So length of the first string is 1, 2, 3, 4, 5, 6, 7, and second string b, d, c, that means 3, 3, 6. So that's why I have to create a matrix of 7 cross 6. Actually it is 1, 2, 3, 4, 5, 6, 7, 8, 8 cross 7, because initially there won't be any comparisons. So I will need one cell extra for both columns and this thing. 7 cross 6, this is 7, yes or no students? This is 6, I'll just take one extra row and one extra column. So we'll make it 8 cross 7. Why? Because initially it will be 0, there won't be any cost. To accommodate those things, I need extra things. Okay, now let's see how this algorithm works. So the things that I'm going to show you, actually trick in the sense, when you say dynamic programming, you should run this algorithm. When you say dynamic programming, you should run algorithm, and in fact in the exam if you run, because this is very easy. First is that LCS length is x comma y m comma n. So my m size is 7. So this is 7, this is 6. Okay. So initially if you see 1 to, how much it will go to? 1 to m means 1 to 7. So 1 to 7, that means 1, 2, 3, 4, 5, 6, 7. So 1 to 7 everything will be this follow line number 2. Students, line number 2 1 to 7 all 1 0, that means 1 0, 2 0, 3 0, 4 0, that means column 0 row 1 everything will be 0 0 0. Friends, and then line number 4 j 0 comma 2n c 0 j, that means 1 to 6 0 1 0 2 0 3 0 4 up to 0 6 everything will be 0 0 0. So 0 0, and then you have this line number 6 for I goes to 1 to 7 and j goes to 6. These things you have to check. Okay, now let us see, this is xi and this is yi. This is my first trig, which is x, a, b, c, b, d, a, and second one is b, d, c, a. So every time, so this is, and then finally, and then here, because it's a tabular thing, so this is the main table which will calculate the cost, and then you need a direction, which direction my recursive algorithm will move. For that you have another array, this is the C array will hold the cost. C array is a cost array, okay, that will, all the things it will save the value here, C array. Another array is there which is called B, that means you can call it C table. Another one is B table. C table and B table, okay. So C table, what is happening here? B table actually will guide you in orientation. That means which direction you should move, because this table will be full of values. Which direction you should move? That means you should backtrack when the bottoms up will happen in the recursive algorithm. Which direction you should move so that you will get the best result. Okay, that table actually a B table. So B table holds the directions. So here 3 types of directions are there. One direction is the upward direction, upward arrow, and here actually 2 array. Differently also you could have done, but for the sake of easiness they have put everything all together in a single diagram. So first is upward direction, another one is horizontal direction, another is diagonal direction. So diagonal direction is important because this will guide you whenever there is a match, that will be a diagonal direction also. But when you have this thing, you have to actually, if you go with the full dynamic programming way, in exam purpose you can, this trick that I am going to show you will work, but normally when you apply everything in coding and all, this code should be there, otherwise it will miss dynamic programming characteristics. If you deviate from dynamic programming anything, it won't be a dynamic programming anymore. Okay, so you see here, I'll just tell you the trick, very simple. Whenever there is a match, let's say this is A and this is B, okay, and already you have 0 0 0, I don't know which value will be here, how to. So let's say whenever there is a mismatch, that means A is not equal to B, that means let's say I'm comparing this A with this B. A is not equal to B. When there is a not equal, that means not matching, that time what you have to take, you have to check this diagonal, and whichever is the maximum, that value you have to put here. So let's say here it is 1, even though not matching, if it is 1 and it is 0, so you'll put here how much? 1. But in this case 0 0, so you put 0, there is no match, 0 0. Instead of having here, students, instead of saying that it is borrowing from the left arrow, we will say that it is coming from the right arrow, I mean upper arrow, upper cell. So let's say this is 0 0, maximum of diagonal thing 0 0, maximum is 0 only, and we will say it is coming from the up, not vertical, not horizontal. From the top cell it is, we are borrowing it, okay, and we will maintain this across this whole solution. So This is not this, this is this. This also this. A and C matching, students? 0. A and A matching. Now when there is a match, these two options you understood. When there is a match, situation is something like this. Let's say this is A, this is A, this is 0, 0, 0. Whenever there is a match, we will just add 1 to this cell. This is 0, no? Whatever value will be here, plus 1. Okay? Let's say this is 2, so 2 plus 1, 3. So 0 plus 1, 1. And then you have to put a diagonal arrow. This is very important. Diagonal arrow. So whenever there is a match, A and A is matching, and then 0 plus 1, 1 you have to put, and then diagonally. Okay, diagonal you have to put whenever there is a match. So A and A is matching. So 0, this 0 plus 1, which is how much? 1. And then you put a diagonal arrow here. A and B is matching, students? No. So maximum of 1 and 0 is 1. But this one has come from this side. We will intentionally write. A and A is matching again. So you put A and A is matching. So we will do this 1 plus 1, which is 1. And we will put a diagonal thing. Similarly, B and B is matching here, yes. B has been matching, and 1, 0 plus 1, 1. So sorry, this will be, put here 1, 0 plus 1, 1. Diagonal. B and D, 0. Like that. You can fill this whole thing. You can fill this whole thing, and then finally it will look like this.
Is there B and D maximum?
One second. Maximum is 1. Sorry, you have to tell. B and D is not matching, so maximum is 1. So this will be 1, and your arrow should be this side. Correct? So you can fill this whole thing you can fill. So once you fill it, it will look like this. So this is the full table. Now it is easy. Now it is just a recursive call that you have to solve. Once you prepare this, so what you will do, here the call will be 7, 6. Right, students? So 7, 6. So if, don't talk now. This is print LCS, the second function. So first function is this one, length of the LCS length, and second function is print LCS, is the final function, okay? Which will display which are the participant of the characters in the S1 string and S2 string. That means longest common subsequence, which are the actual characters that are participating. So 7, 6. So you see I equal to 0, j equal to 0, return. So here it is so false. And then if Bij equal to diagonal arrow. So Bij means you have to go 7. So Bij initially 7, 6, right, students? 7, 6 it will go. Is it a diagonal arrow, students? No, it is a upward arrow. So if it is not the case, it won't enter line number 3. It will come directly to line number 6. Yes or no? Line number 6 says that if 7, 6 is the upward arrow, which is true. Yes or no? Now here two recursive, line number 7. So once it is true means it will enter here. Now it will be like LCS Bx comma, this is I minus 1, I is 7 minus 1, 6, and this is j is 6. So you have to go directly to 6, 6. So this is how this diagonal arrow is. So this is 6, 6. That means 6, 6. You are here. Okay, 6, 6. So if you go 6, 6, then okay, you go 6, 6. Then it will be like, it will call it. Now it is no longer this 6, 6. It will come. So whether B6, 6 is a diagonal arrow. If it is the case, then print LCS, immediately one recursive call print LCS B comma x comma 5 comma 5. Yes or no? So diagonal fellow is actually guiding you properly. The upward and horizontal fellow is not able to guide. So it is 5 comma 5. So you have to go 5 comma 5. And then once you comes out, it will, because now it has become 5, it has become 5. It will print x, how much? So this 5 comma 5 call will come here, students, 5 comma 5. 5 comma 5. But when it is leaving, what it will print? 6 xi, x6 will be printed, x5 this the I5 call is there, but initially you started with 6, no? 6 and how much? 6 you call. So this 6 I value is 6, this is you entered, but when you it is x6 only, so x6 is nothing but a, it will print a here. Then it has gone to 5 comma 5 is this one, which is again a upward arrow. So if it is upward arrow means again here 4 comma upward arrow, it will come here 4 comma 5. So 4 comma 5 call will be there, 4 comma 5. 4 comma 5 means again a diagonal arrow. So you print B. Okay. And then again you have this, this is C will be there. And then finally you will be having B. And then it will start returning. So it will return from here. B, C, B, A. Time complexity also O, M plus N. Okay, students. So this is using dynamic programming. Dynamic programming we have solved longest common subsequence problem. Now you can see the code is very simple.